Hey guys, we're going to watch this video together and actually do it. And we're going to figure out how to find the angles inside of a right triangle using inverse trig functions. So for inverse trigonometric ratios, we will use this reference triangle, or use this triangle as a reference for us to set up our three inverse trig functions. And if you know SOHCAHTOA and you know how to set up your sine, cosine, tangent ratios, there's just one more step that you just have to figure out when you have to find that angle. So let's take one for example. We're going to say let A be, or angle A be, a measurement of an acute angle. So if we say that if the tangent of A is equal to the opposite side, which is BC, over our adjacent side, which is AC. Okay, so notice how the tangent of A is equal to this ratio. Now, if we want to actually figure out the measurement of that angle, we have to use inverse tangent. So then, if the tangent of A is actually equal to BC over AC, then we know that the measurement of angle A is equal to the inverse tangent of BC over AC. Now, the inverse tangent is the button on your TI-84 where you have to press the second, which is in the top left blue button, and then you press the tangent button, and then you'll see the inverse tangent, which is tangent to the -1 power, come up. And then you type in your ratio of your tangent function from earlier. Okay, so that's how you'd figure out the measurement of angle A, using the tangent function. Okay, so then let's use sine. So if the sine of A is equal to the opposite side BC over the hypotenuse AB, to figure out the measurement of angle A using sine, we'd have to use the inverse sine. So the measurement of angle A is equal to the inverse sine of BC over AB. Final one, if the cosine of A is equal to the adjacent side, which is AC, divided by the hypotenuse AB, then we know that the measurement of angle A is equal to the inverse cosine of AC over AB. In example 1, we're going to use an inverse function to find the angle measurement. So we're going to find the measurement of angle A to the nearest tenth of a degree. So our reference angle is A. Okay, so we're going to draw our little eyeball on A, because that's the angle that we have to find. And if you look at the triangle, we're given the opposite side and the adjacent side. So we're going to write down opposite over adjacent. So then we have SOHCAHTOA, in case that you don't know how the trig ratios are written. And because we only know the opposite side and the adjacent side, we're probably, and we are most definitely actually going to use tangent in our problem today. So we have the tangent of A. The tangent of A is equal to the opposite side, which is 16 over 20, which is the adjacent side. Now, you're asked to figure out what the measurement of angle A is. In order for us to do so, we have to take the inverse tangent. So then these two positions actually just flip-flop. So the angle A and the 16 over 20 actually flip-flop. So the measurement of angle A is equal to the inverse tangent of 16 over 20. And again, the inverse tangent is a function in your calculator that you need to type in. So when you type that in, the measurement of angle A is going to be equal to 38.6598 degrees. So make sure that you are actually in your mode and your calculator is in degrees to get the correct answer. Alright, so we can practice these using the inverse function in this example. So let angle A and angle B be acute angles in two right triangles. Find the measurement of angle A and angle B to the nearest degree. So in A, if they already set up for us, sine of A is equal to 7/10, and we have to figure out what the measurement of angle A is. So we use the inverse function of sine and put 7/10 in the parentheses. Calculate that out. The measurement of angle A is 44.4 degrees. Okay, so with B, to find the measurement of angle B, if cosine of B is equal to 9 over 13, the measurement of angle B is equal to the inverse cosine of 9 over 13. Type that in your calculator, and we get 46.19 degrees. Alright guys, thanks for watching. Stay tuned for part 2, where we have to use the inverse functions, inverse tangent, sine, and cosine functions to figure out not only the angles, but then we also have to solve a right triangle. So stay tuned.